Now there are a couple of things that we could do to improve our code before adding new features. The first thing is where I'm using the number 10 to control my for loops. Here the number 10 is really the number of items in my lists, 10 duck species and 10 duck counts. And if I were to add another type of duck, then I'd have to change these numbers as well. As I mentioned before, if you find that you're changing a lot of code to cater for what seems a small change in requirements, then it's likely that your code needs improving somehow. So my first change will be to somehow work out how long the lists are rather than using a fixed number. The second thing is a bit more obscure. When I look at my calculation for getting the total duck count, it seems to be that my code is a specific example of being able to find the total from a list of integers. It doesn't really matter what those numbers represent, I just want to add them together. So my second change will be to make my calculation more abstract to deal with any list of numbers. Now both of these changes are going to involve the use of functions. We've come across these already as both print and input are Python functions, but I want to talk about them more generally now. After you understand what functions are, you'll find yourself using them again and again. Here's a block diagram showing the idea of a function. You can think of it as something that carries out a specific task based on information you choose to give it. And after completing its task, it may return you some information to you. A function has a name, which is what you call when you want it to carry out its task. Here's an example called add1 with an argument called x being given to the function and an argument called y being returned. And here's a specific example where 1 goes in and the function adds 1 and 2 is returned. A more human example of a function would be if you consider your friend James as a sort of computer. Let's say he has the TV remote and provides a function called change TV channel. If you wanted channel 2 to be on, you could tell James change TV channel and provide the number 2 as part of the call. James would then carry out the task and you would see the channel change. You don't need to know the details of how he does this, you just make the call and see the result. Here's the Python print function as an example. It's one of Python's built-in functions. You can also create your own functions, which we'll look at later, but in general a function is defined by its name and an expression in brackets called the argument. With the print function, its name is print and the argument here is a string. Some functions return a value to the caller. An input is an example of this, where it returns the string that's been typed into the keyboard. Let's use another of Python's built-in functions, so that rather than using 10 in my code, I use the length of the list instead. The function is called len, and it returns the number of items in a container, where a container, for example, could be a list or even a string. By the way, if you want to know what a particular function does, you can use Python's help function. Just type help and then the function name like so. Anyways, back to the len function. If we wanted to get the length of the string hello, we would type len hello. Length in this case means the number of characters in the string. Other things will give an error, like using the number len7 as the argument as an integer doesn't have a length. Here's another example using a list of car makes, Mazda, Ford and Nissan. Passing car makes as the argument to len returns 3, the number of items in the list. Similarly, with a list of numbers 0 to 5, len returns 6 as you would expect. Let's use these IDs in our code so that we don't have to use fixed numbers. The first 10 refers to the duck types list, so we create a new variable duck types length and assign whatever is returned from len duck types. Next, change the 10 to the variable duck types length. Then for the calculation, create a new variable duck counts length and assign it len duck counts. Use this new variable in place of the 10. As before, let's run our code and test with our usual numbers 0 to 9 for the counts. As I'd hoped, all 10 duck types are shown and our calculation is correct, meaning that our code changes look okay. The second change I wanted to make was to make the calculation more general, as it's really just summing a list of integers. Now Python happens to have a built-in function called sum that will add our numbers together, but I'm not going to use it for now. Usually though I would, but as we're learning about functions, then we're going to create our own function to do the same. Here's the general structure of a user-defined function. In order for Python to know what follows as a function, we have to use the keyword def for function definition as the very first thing. Next we give the function a name, then brackets and a list of parameters. Then we use a colon to indicate the end of the definition part of the function. Underneath this we write the body of the function, suitably indented, which are the steps the function carries out each time it's called. Let's do a couple of examples using the Python interpreter in the console. We'll start simple with a function called printSum. Its job is to print the sum of two numbers. It doesn't take any arguments for now. Here's the header part of the function, def printSum. Then the body of the function consists of two numbers, 1 and 3, added together, and a print statement. Press return twice to get back to the prompt. Notice that nothing happens as we've just defined the function, not used it. So let's call the function by typing printSum. Make sure you use the brackets. We've called the function and it's done its work, printing out the total 4. Let's change our function to print the sum of any two numbers. It's the same function definition, but this time we have two parameters, num1 and num2. And inside the function body, we're going to use these parameters as variables in the total. So let's call our new function with different arguments. PrintSum with 123 and 45 prints 168. PrintSum with 123 and minus 45 prints 78. PrintSum with 123.5 and minus 45.1 prints 78.4. Wow, we've just made ourselves a happy little calculator. Now, rather than printing the total in our function, let's return it to the caller so that they can do it. Now, by the way, you should try and separate tasks that your program does from the parts that take input and print stuff. So having a print statement inside of this function is bad design. To return values from a function, you use the return keyword. In our case, we want to return the total, so we change our function to this. To use what's returned, we need to assign it to a variable. I'll call it the total and print that. Rather than using two parameters, we'll use a list of numbers instead and loop through them to work out and return the total. I'm also going to change the name of our function as it's not printing anymore, and I'll change its name to calculateSum. Here's the definition with one parameter, numbers list. Now this parameter could be named anything you like, but it should be descriptive. In the function body, we need to loop through each of the numbers in the list and add that to a running total, which I set to 0 initially. Our for loop goes through the numbers list, assigning each value in turn to the variable number, as you can see. We don't need to use indexes here as we're just reading items from a list rather than changing them. Let's call this function with a list of numbers. I'll create a variable ages and assign a list of values to it, 12, 8, 56 and 24. Then I'll call our function with this list as an argument. Finally, I'll print the total. It's 100. Now just checking in my head, 12 plus 8 plus 56 plus 24 is indeed 100. We can use this function to calculate our duck counts total. So we've learned how to write our own functions. Now let's update our code to use a function for the duck counts total. In Python, you have to define a function before you can use it. So go to the top of the file and type in the function to calculate the sum of a list of numbers. Now update our code to call the function. Total duck count equals calculateSum duck counts. And finally delete the old code as I'm confident it'll work. Run the code and test using our usual numbers. Everything is okay, so it looks like our function is working. Notice how the main body of our code is now more readable as we've broken the steps of the program into reusable chunks. Just a quick word on how a program is executed in Python. I've written a small example to illustrate. As you know, Python starts at the first statement in the program and continues in a sequence one at a time. function definitions are ignored until they are called. So the first statement that gets executed here is x equals 3. Python then assigns 24 to the variable y and then calls a calculate sum function using the variables x and y as arguments. Now the function is like a little block of code on its own that is self-contained. None of the variables inside the function are available to the outside program. In fact, they're called local variables. So if I typed print total here, you'll see I get an error when I run the program. By the way, num1 and num2 are called the parameters of the function as opposed to the arguments x and y. Now what Python does when it calls a function is to assign the values of the arguments, here x and y, to the parameters num1 and num2. So num1 gets 3 and num2 is assigned 24. The total variable then gets returned and is assigned to the variable x plus y. When the function returns, all of the variables inside are lost, and when it's called again, new variables are created. Well, that's about it for our initial discussion about functions. We've learned about the built-in function len and defined and called our own function. At present, all of the data we enter for our duck survey disappears after the program finishes, so in the next video we'll look at how we can save and then retrieve this information.